be that we start with the Siemens presentation, and then next we do the, which one next, Lars? The signaling presentation, then? Which one? Which one? Ah, the fleet management, okay, perfect, okay, and then the Aclio challenge, and then the second AWS IMT challenge. So this is the order, and so we'll start with the Siemens challenge. The jury is ready. Everybody is concentrated and feeling good. Very good. Yeah, we have 3 microphones. You can connect your computer here. Yeah, so the floor will be yours. You have 8 minutes. And if you want to demonstrate something, you can use 2 minutes in addition for the demonstration. So you can talk 8 minutes and then present your demo 2 minutes. So then we have 10 minutes per team. We have 5 teams, so this will be 50 minutes. So we should be done within the hour. Okay, so take as many microphones as you want, and the stage is yours.
I hear as well, but you can.
The presenter?
Is there a sound? Because we have a video.
Or if you have sound, that's also possible, yeah?
Where's the presenter? We cannot see.
This one? 2?
No, it's good. No, it's
Okay.
Yeah, hi everyone. I think we can skip the introduction because you all know us already, and I hope you also know our names. Our challenge was an AGV for the factory of the future, and an AGV is an autonomous guided vehicle. And yeah, in the next few minutes, we will tell you a bit about our challenge, give you an overview. We will tell you about our sub-challenges because we split our main challenge into sub-challenges. We will tell you about the problems and the goals of each of our sub-challenges. And we will give you some insights about our technical realization and the results. And in the end, we come to a conclusion and tell you about future work of our topic. This is our challenge. What do you think? What do you need to bring this package of cornflakes to an angry AGV? And yeah, the only thing you need is just 5 engineers. And these 5 engineers work on 4 challenges, or worked on 4 challenges. And here you can see we needed to implement an industrial edge management, as well as autonomous navigation for the IoT board. This is the IoT board, and this IoT board should bring this package of cornflakes to the hungry AGV. And to grasp the package, of course we need grasp planning for the robot arm, and as well we need secure communication because there can be intruders, for example other hungry AGVs who want to steal the package of cornflakes.
Okay, so as Michael said that we have divided our objective into 4 main challenges. So the first one was to have the continuous integration of software on the multiple robot. And the main problem is that we had complicated software deployment for many robots. For the second objective, we needed also to have autonomous navigation for the IoT BOT and to provide a product for further processing steps. We also wanted to grab an unknown parts in order to detect the objective in camera space, like in how camera space 2D, and that is being related to the robot space. And our fourth objective was to secure the communication between the robots, because the possible intruder can attack the communication in the ROS2.
So, just as Milko said, we have to let all our robots work together to bring the cornflakes box to our goal. And yeah, for now, the software implementation is done separately on all the different robots, and also the versioning is a lot of effort. So one goal is to do a continuous software implementation on multiple robots. And to get there, we use the Siemens Industrial Edge environment. So basically what we did is to take the ROS2 packages that we need for our robot fleet and build Docker files, Docker images, to then publish them into the Industrial Edge app publisher, which is building the Edge apps and then publishing them to the management system. And from there, you can easily deploy all the software to all the Edge devices, so basically all your robots. So as a first goal, we took the MoveIt package, a ROS2 package that is used for planning, manipulation of the robot arm. So yeah, basically I built this Edge application like I just explained it, and you can see the Edge app in the management system here on the right side. And we then deployed it on the robot arms, on our big fella with the robot arm. So then afterwards, Sandro could use the software for his task. He will talk in a minute about. Yeah, and as a result, we have now an automatic
autonomous navigation
Okay, perfect. Thank you very much. Very nice, very impressive. The next team is the IMT signaling class, right? Okay, yeah. Do we have questions from the jury? So I'm also in the jury. So my question would be about documentation and. I switched side. My question would be on documentation and reproducibility. Can you say something about that? How did you document it? How do you ensure reproducibility?
Yeah, we had a grateful backup from the Siemens team, and we shared everything with them. So we documented most of the important steps we did, and of course the code. And we produced Docker images.
Okay, you produced the product already with your industrial edge.
Very good.
Sorry, I was just excited because you told that you did images, etc. I just wanted to add, you created here a product, the Move It Docker Edge app you just developed, is now, to state it out how cool it is now accessible to every person on the earth, or could be accessed by them.
Cool. And another question is, how was the collaboration between you and the Siemens people? So how many were your own ideas? How did you interact with them? So how was your work mode?
I don't want to answer all the questions. Do you want?
So they were really friendly and they were always with us. So we really enjoyed. Yeah, so we really enjoyed when we were working, and we also learned a lot of things together. So they were really helpful, and they always answered the question, and they provided us with everything that we needed.
Perfect. That's what I always hope for. Yeah, so these would be my questions. I just hand over the mic. If you don't have a question, you can just give it to the next person.
So I would be interested in the following. What essentially was your starting point? What did you get as given, and where did you start from?
There were already packages for most of the features available. And I think the biggest challenge was to get them running and to let them talk to each other, because networking communication in this field of robotics is hell. You want to add something? I think you had like the biggest problem at the end.
Yeah, on my side, the marker detection for these was there, and the commands for the robots were theoretically there, but getting them to run was a bit of a hassle. And yeah, so in between, it was our development.
For me, the implementation of to do the simultaneous localization and mapping and the navigation was not provided by Siemens, so I implemented.
Yeah, so to make it complete for my task, I used mostly the open source ROS packages, but of course for the Siemens industrial edge environment, I needed all the access stuff, and got some input from the colleagues how to use it, a tutorial. So yeah.
So maybe one more question from my side. How was your definition of the roles within your group? Was it like that everything you did during this challenge was like a team effort, or did you define roles at the beginning, and maybe just add a little something to that?
Mm-hmm. So in the beginning, we first had to actually came up with the basic idea what we want to achieve in the end. So letting the robots talk to each other, letting them work together, and according to that, we then figured out what there's important, what there's to do to get there, and then spread it around the tasks among us according to our interests. Yeah.
Okay, very good. Thank you very much also for the very good answers. Give them once again a warm applause, and then we come. We come to the second team. Either you bring your own computer or Erkin is opening it, as you prefer. No, the second is signaling, so yours.
Anna, can you take the click and then just, because you're the next? Hey, test.
Test. It's on, but no.
No, it's fine. Just point out to the laptop. Point out to the.
It's too small, but
Can I?
yeah. You can increase the size of the. I think no. The beam.
No, no,
The beam of the net.
So there is a few seconds delay. Be careful. Left, right. Okay. In any network.
Okay, hello everyone. Nice to have us here and thank organizers to make it happen. And I will present our team. We no more the team number 2. We are color busters. And I need to highlight the competence of each of our members because everyone has different competence, but it fits really perfect. And it fits and flourish our project. You will see later how it works. Wait. Okay, so the topic you can see is like machine-to-human signaling via the different devices, and our main task proposed by the organizers at the beginning was to create a system for controlling low-cost IoT hardware. Of course, we were given different devices. You can see the initial setup that was proposed, and there was not all the devices that you can see here. And of course, we were considering about the specific use cases and features that we need to implement. And of course, the goal of current setup was to be innovative and create a complete system or software for the Raspberry Pi that can operate different IoT devices, of course, using the specific technologies listed in the proposal. So this was the initial setup. Of course, we did a small catch-up before the meeting. The main challenge, it was on Friday, where we distribute all the responsibilities and our competence according to the timeline. And it works well, but I need to highlight that there was a tough deadlines, a lot of coding, a lot of reverse engineering, of course, unexpected implications, and a lot of scripting and pooling. And then I hand over to Anna Maria.
Okay, of course, anytime we had to develop an IoT system, we have to think about the architecture. I think this is the most important thing at the beginning. So we have drawn here the main components of the IoT architecture. We used a layered one and a modular one in order to be scalable for the future applications. I mean, it's very important also for the debugging part. To have a layered architecture and also for other purposes. After that, our architecture is also extendable and configurable. I will start with the first layer. We have here a three-layer architecture comprising the devices layer, the network layer, and the cloud layer. On the devices layer, we have the devices proposed in this challenge. We have an alarm clock, 2 LED strips, and the audio meters. Each of them communicated with the next layers based on different protocols. We chose the Raspberry Pi as the main component that deals with the different protocols. So we have the alarm clock and the LED strips communicating by infrared communication, and we have also the audio meter that communicates through Bluetooth Low Energy communication technology. Of course, because we have the infrared technology here, we need the MQTT infrared gateway. So the Raspberry Pi will send the commands to the MQTT gateway and also to the audio meter directly using the Bluetooth Low Energy. Of course, we have designed also an application you have there in the cloud layer. So based on the MQTT messages that can be sent from the platform, we can control each device in our system. Moreover, we envision this timing history database for future development purposes, as we want this to be a platform that helps the speaker improves his speaking skills and his keeping time skills. I will pass to the next slide. So we had to face different challenges. We have to connect different devices with different communication technologies, so we had different protocols. We had to pipeline all the signals in one stream, and we have to develop a very informative dashboard. We have used Python and C to develop our backend and front ends. Here you have a small list of all the devices that we have used. So I will begin with the hardware list, except the Raspberry Pi, the clock, the timer, the light strips. We have used also an MQTT to infrared gateway. We have used also Raspberry Pi as the Wi-Fi access point. And we have here also a list of software used. We have used the MQTT broker, the Mosquito, Eclipse, and HTML, Java, and many others. And as protocols, Wi-Fi, infrared, Bluetooth Low Energy, and MQTT.
Okay, so as my colleagues mentioned, we basically wanted to create a smart speaker system, a smart conferencing system, and since this is IoT, we wanted to connect different devices. Now, all the devices that we listed before, they're all heterogeneous. They all talk on different protocols, they all talk on different communication technologies. Some use infrared, which is light, some use Bluetooth, which is radio, some use USB, which doesn't work. So what we wanted to do is we wanted to bring it all together and have one command system that we give to Mark after this summer school, and then he can control and basically manage the experience of the speakers, which is us right now. And what we did was we had these clocks, which was basically, you can see there as the time, if you turn back, the white one. We'll also show this in the demo, don't worry. But the idea was to have an indication from these devices, from these heterogeneous devices to the user. And more than anything, what we developed was a framework which is extremely scalable and expandable. And all of this comes together in basically a way that all these heterogeneous devices, they can talk to each other. We have a software which manages all these different bridges, and we make a provision that if tomorrow you want to add a new technology, let's say Zigbee or LoRa or something new that the scientists at TU Berlin come up with, then we can also add that easily. We can add that bridge easily, and we can provide a way for different people to reverse engineer yourself. So if you buy a cheap or a low-cost IoT device, like a LED strip which reacts to sound, or for example, a smart speaker system, there is provision in our code, in our entire system, to easily incorporate that. We give you a very clear instruction of the how-tos that you need to follow in order to read to that step. And we can also show you how you can use this code base through our GitHub, which we can switch to. Yeah, and Marvin can maybe walk us through the GitHub repository.
Yeah, thanks. Like we will see in a couple of seconds, we have a little bit different folders and topics here in our GitHub repository as you are able to implement or to use what we have in here. It's a public repository as Mark Oliver can access it right now and copy it and give it to other students. Scroll up, please. So we have a folder which contains configuration files. We have a folder which contains daemons, which has to be installed in the Unix Raspberry Pi system and started and enabled. We have a folder with how-tos and some other folders with the two MQTT bridges, one which is for accessing a Bluetooth device, the other bridge is for relaying the commands to the different IR devices. And all this, there is program code located there which is executed by the daemons. And here we have the main logic program. It's a new app.py, currently not that bad the name, but we were a little bit in a hurry. And that app contains the logic about our program and the dashboard and interface. So if you just go in the configs file for me right now, here we can see, for example, just open please the JTX commands.json. The JTX commands in this case here are commands just for an IR remote. And here have we the predefined commands, what the JTX device can handle. And these are the IR commands we have reverse engineered. So if you add another device, you just have to add a JSON file, define the commands, and add these commands to the logic at the top level script. And this is how it goes.
So simply adding another JSON file in the configs folder with your device that you reverse engineer, you can add that device and make it part of the same system very easily. So it's simply the steps are add one device and it's done. Okay, back to the slides, please. So meanwhile, I'd like to discuss, because we talk a lot about, yeah, one back. Yeah, here. So one of the really interesting challenges, like we had a lot of challenges because reverse engineering anything is not simple. We had no data sheets, no libraries, nobody we can call up and ask, hey, why did you make this protocol this way? Or what does this bit mean? Or why are you sending this logic? So that left us with basically starting from zero. And one of the most interesting out of all the reverse engineering we did, which is a lot of infrared remotes and playing with lights all day, one of the most interesting things was reverse engineering Bluetooth, because it is not very easy or trivial to really see these packets because you need specialized hardware. So what we did was we used a bunch of different Android phones, some of them from the audience members, some of them from our team members, none of them in English, to basically figure out what are the Bluetooth messages being sent across. And this is some of the packet that we captured. There was a long process of how we set this up. This is also in the how-to, so you can quickly do this and try this yourself. And then we finally ended up with this big number, and then like some movie about a mad scientist, we started scribbling everywhere what each bit means and started changing these bits and seeing how the lights are changing, and we finally got it to a level where we were like, okay, with this much knowledge, we can send the right color and we can send the right on and off commands.
So, in the aim of these protocols that my team just mentioned, there was main requirements, which are the develop and run the system with the proposed devices and the control devices like the clock and the alarm and the lights. There is more extra challenges for us. It was like pipeline various devices in one stream and incorporate different use cases scenarios with creating a dashboard with UI that you can easily control everything through this API, through this dashboard with a cross-platform scalable by design systems. So there is a pros, there is no cons for the system. It's configurable and scalable. 4 devices were reverse engineered and with a tremendous progress. And of course, the concept is one. So we can reverse engineer any IR device, and we can simply add it to our system. So the use case modeling, as we see, it's intelligent multi-protocol solution. As we say before, there is a scalability and heterogeneity and sustainability with a circular economy and a user-friendly that helps any user to easily just to manage everything in the office or the home, whatever. So as a scalability, number of the devices that can be inserted by time, it doesn't affect on the network and affect on the system. Of course, it still robustness and the heterogeneity because can be adapted to different interfaces like MQTT. And for the sustainability because it's a low power and it's a low-cost device. And for circular economy, it's a reconfigurable tool in the aim of reusing in home devices. So, like, no need for buying a new remote, or it's just easy to add a new device to this system. And it's a comfortable speaker environment. So, I think so I can. Yeah, thank you.
Okay, so we have also some future directions of improvement. For example, our team started to deal with the gesture recognition based on images, but as a future as a feature, we can add also RGB gesture sensors. Also. We can implement a module to assess also the audience engagement based on video processing. Also, we can control the system based on the multimedia content, and it would be a very useful feature. After that. We can extend with other interfaces. We can include smartwatches and to use other protocols. Concerning the cybersecurity threats, I will give the word to Suri.
Yeah, so just to be very quick with this, we tried the AWS, thanks to the AWS colleagues here who basically set up a network in 1 hour, and then we trained 1, 2, 3 so that we can basically point to the camera and say, hey, set 3 minutes for me, and the entire system powers up with the clock running, with the LEDs setting to the right color, and over time, the LEDs indicate to you how much time is remaining, and to the audience is how much long do I have to endure this talk, and basically you can see the progress of the talk through the color indication. For the security, it's really important for this to be secure, so we air-gapped the system. That means that the Raspberry Pi creates its own Wi-Fi. That also means that you can take this and go to any country as long as the Raspberry Pi is plugged into the power. It will create a Wi-Fi network where all the devices will find each other and work. So the thread definitely is not completely secure because the messages are not encrypted yet, but it does not mean somebody malicious can log in and start messing with your lights, because that's really a dangerous situation.
The following.
It's a feature, yes. It's not a bug, it's a feature. And lastly, the demo. So maybe we switch to the dashboard. It's a really nice dashboard to match the color scheme of the Einstein Center.
Yeah, we wanted to match the colors of the center.
Yes, and I will simply start the timer here. So I would just like you guys to turn around.
Behind that, you have the same dashboard. So right now, there should the enter time be shown on the clock.
Yeah, so all the devices just near the camera.
So the clock should show the time which is Suri just entering, and after that there is a countdown running down to indicate how the time is, how long time, or how the percentage of time he has left for his presentation. All the different devices in the room here show a different color. So you'll see the indication bar there up and going, which is matching my voice. This should be at first green, and further he comes to an end, it should become red or so. Also, the LED strip should take a color, and an LED strip on the table there should also change the color.
So as Marvin explained, I just started the 2-minute timer, and as you can see now, I have 2 minutes to wrap up this talk or I'll be kicked out. We also have the same system being shown through the other LEDs. So this basically toggle through the color showing, okay, the talk has started, you still have time, and as slowly you're watching, maybe you're too nervous to watch the timer and you're like, oh my God, I have 32 seconds now. And instead of that, you can also look at the color, or to make it more subtle, the audience can quickly glance to the color, like, okay, red, it's gonna end soon. Or they can look at the green and like, there's a lot of time left. And this is basically an indication for how the machine is signaling to all the people present in an autonomous way. This is the time remaining. This cycles through, and when the time is up, this makes a very annoying beeping sound. So maybe before it does that, we wrap this up.
So,
Yeah?
so now you see the green color, so it will change. So it started with a very light color at the beginning, and now we have the green color. Now it turns red because we are approaching the final of the speaking session.
The bar. So the LED bar is not synchronized, right?
Just a little point that when the time is going to be finished, this is LED strip just make like flickering that shows that the time is going to be over. So it's like a network.
So we have a technical limited use case here right now. There is an LED sending IR light, and like you see, this LED bar right now. Oh, now it matches, but before it didn't match. Sometimes the diodes just don't receive the light, and so you have to install it properly. The LED has to be high installed, and sadly, this is not high enough installed right now. So we have some inconsistencies there. But
yeah, but it's going red.
So.
Okay, so the time advanced. So thanks a lot for the presentation. Once again, jury questions, really quick as they were a little bit over time. So how robust is your solution? So you will say no, perfect, because it doesn't have any disadvantages.
Technically wise, it isn't that robust what the technology, so the IR technology limits. So we have no feedback by getting if the IR signal reaches its destination. Daemon-wise, so in the implementation, we had some robust consistency as well as robust mechanisms, like if the Bluetooth connection isn't there, it tries continuously to establish a connection again and to resend the signals and all so on. So we have addressed that in the design of software, but we had some limits according to the IR technology.
Mm-hmm. Okay, good. And that was my question. I hand over to Adam. And for the upcoming talks, if this solution is working, you could set the 10 minutes timer.
Following issue, you have mentioned the 2021 solution and emphasized that there is a huge progress. What was the level of the solution 2021 and what is the progress?
Yeah, I can talk about this. Last year it was a similar challenge, but the only thing that team succeeded in was to reverse engineer only the clock. Nevertheless, we have reverse engineered 4 devices, and we have implemented an end-to-end system. I mean, from the devices to the dashboard. So, in my opinion, it's a great progress.
Okay, thanks. Also, the reverse engineering of the clock doesn't say how to turn that off, like the beeping sound. So we also had to do that. So there were some additional steps that we took from their implementation. They had a basic level of the program mapped out, and then we built on top of that.
But the architecture we made?
Everything we made, everything else we made.
We can add more devices, just it's all about how to reverse engineer it and just implement it on the system.
Quick question, possible from outside jury? No? Yeah, last time there was it's not a fair play. Okay, then yeah.
I have a very short question. So you might remember my background is not in computer science, so maybe you can quickly explain what exactly reverse engineering means and to understand where you started from.
Okay, so basically every single device speaks in a certain language, and if you go to listening to these devices, you don't know what language they're speaking, you only know that they're speaking. And then reverse engineering is to basically translate a signal in the air to an actual meaningful contextual information. So, oh, turn the LED red, turn the LED blue, turn off the light, start the timer for 2 minutes. All of this is information that they share, but because this is not available to us as end users, we have to basically go into the system and snoop, like spy on them and listen to them and then try to see, okay, this is how the communication might work, this is how the messages might look like, this is what I need to send in order to make the device behave a certain way.
Okay. Thank you.
Okay. You have a question? Then thanks again. Thanks again. And the next team is the FUB Fleet Management Lars, right? Yes. Okay, then please, the Fleet Management team.
Thank you.
Who's going to be controlling?
It's short, it's longer.
So this goes that way. Wait, how do I use it? Do I have to point somewhere specific?
No. It works before.
Okay, you control it and I'll point to you when you should move it, okay? Okay, so we're the IoT Fleet Management, we're on the IoT Fleet Management Challenge. Yeah. So, hello everyone, we're on the IoT Fleet Management Challenge. And if you could move on to the next slide, we can see that basically our challenge was quite different from the other challenges in the sense that we were given a design challenge. So we were given a broad set of requirements of having to come up with basically a way to generically configure and manage a huge number of devices up to above 500 and above, and to be able to kind of like find a way, an architecture to automate configuration, management, the flow of, for example, data back and forth between a central entity and these devices, how to control that, and so on. And from that kind of like broad set of requirements, if you could go to the next slide, the first thing we did was try to kind of like narrow that down into a specific use case. So where is a use case where we can have a large fleet of devices? So for one thing now that we know in our time is that we spend 90% of our time inside buildings. And one thing that makes the quality of the air inside building incredibly crucial to our health. So what we have is, for example, we look into a building where you can have either a resident or an offices or whatsoever. And what we want to monitor is the level of CO2, for example, and the temperature to be able to know the quality of the air that the people inside are breathing. And so once we have such large buildings, we start to have, for example, multiple rooms, multiple floors, and we want to have multiple different things that we're sensing. So we want to be able to sense as input, as I said, CO2 and temperature. And we want to be able to control things to regulate the air quality in the building, like, for example, opening and closing windows, or, for example, turning the AC on and off, or having a set point to have the AC stay at a specific temperature. So once you start to have this, like 500 devices and above and up to thousands of devices, one thing we want to see is how can we automate the configuration of these devices? For example, the temperatures that we want in each room, when to open and close the window, and so on. So what we need is these devices to be able to kind of like communicate through some sort of central orchestrator on the cloud for scalability through certain access points. And then we want to be able to have our user to kind of like set these configurations that they want initially, and to have the system automatically monitor these configurations and monitor the state of the air quality in the building. And we also want to have a very simplistic kind of like overview for the user so that they can check whenever they want. For example, if you could move on to the next slide. We want, for example, we have two main users of our kind of like interface that we would have in the cloud. We could have someone who just lives in the building, and all they know is that they have a room that they live in, or, for example, an office that they work in, and they care about having a specific, for example, temperature consistent in that room. So they can open the web page. They don't have access to any other rooms. They only have access to the room that they are in. They can see the temperature, the CO2 level, and, for example, let's say they can change the set point of the AC unit to something that suits them more. Another example could be the building manager who actually wants to see an aggregate of the quality of the air across the building and wants to see an aggregate of the temperature and of the CO2 and actually has more overall control and can set the set points, for example, so it doesn't have anything locked. You can actually change the set points and the configurations for any place in the building. If you could move on to the next slide.
Yeah, the first thing we have to do in such a large environment and large application is to figure out who are the actors in all this software development and software application, and which actor will have which functionality to execute. For those of you who are not familiar with this diagram, actors can be humans and machines, and for example here we have a actor access point, we have actor monitoring device, actuator device, which are obviously just devices. We have here the orchestrator, hopefully it's magic. And yeah, now we go a step deeper. We have the user, okay, and how to read. The user we saw before in the portal is edit a configuration on the orchestrator. As just one example. We cannot go through all these details, but just to mention, it's a very, very complex situation we have to take care of, and that's why we now go a step deeper in the communication between the actors, and there is a communication problem. Okay, now we take a look into two of these communication rounds. On the left-hand side, we see just we see the user is editing the configuration on the portal. The information is sent to the orchestrator, and afterwards the user actively says, "Oh, and now I want to update all the devices," or the only one device, however. And then the orchestrator does get that information. Oh, there is a change, it's an event. We have to store the data somehow because there can be messages missing, and then afterwards we can get back the missed message and events and execute them afterwards. And then the orchestrator forwards this update configuration to the access points, and the access point, in that case, we have one access point with one device, but this means we can have many access points with many devices, and then it would be like look like a loop. And as the access point receives the new configuration, it forwards the configuration to the device. Configuration means in that application, it can be a threshold of a temperature, it can be a script, it can be a program, it can be a firmware, it can be more or less anything what we can transfer. On the right-hand side, we see an example where the orchestrator is working absolutely without any human interaction. We have here a timer which requests the monitoring from a couple of monitoring devices, and if there is a temperature given behind the threshold, then we receive the information, oh, here is the temperature from the threshold, and then we execute the actor and close, for example, the window.
I think you should go.
So here comes the question, why we choose the protocols of CoAP and CoreConf? Well, the main reason we have compared CoAP with MQTT for sensor networks from many aspects, as shown in the right side. And we choose the most important two reasons behind this based on our user examples. So first one is that the CoAP has a smaller packet size, so it leads to a faster average transmission time. And the next one is that the CoAP is connectionless. That means our orchestrator can subscribe to a resource without requiring the device to be always online. So it saves the energy consumption on the device. And also, the CoreConf is supported by the open source Riot open operating system. So that's the reasons why we choose them, and that's what we want. Yeah. So please go to.
Right, but how do we make these devices communicate with each other, and how can we address such large amount of devices is actually the semantic that we pushed into the IPv6 addresses, so that we can more fine-grainedly address like a device ID with the last octet, which 1 byte of that indicates the device type, and then we can scale to rooms, then access point, and then floors, so that we can send massively some communication configurations simply using IPv6 multicasting, and then like only indicating the specific ID group that we want to target. So this, we can please go on, is for sure one thing that's really hard to set up at the installation phase, because either these lists are hard-coded at the orchestrator level, but we thought up that this feature in the installation phase might be sort of automated by placing NFC tags and readers on top of a particular access point, so that whenever the physical installation of the device happens, we can have that the human operator that inevitably will install these devices can manually program like just the specific ID that we are currently setting up, and then just use the NFC communication to let this configuration be let's sort of hard-coded to the device. Can we please go on? All right. So we also came up with a young data module. Yeah. Young data module that allows for this sort of monitoring and action sending back and forth from the orchestrator to the devices.
Awesome. Okay, for us products of our network, all systems have limitations. Why don't we explore some of them? For example, coverage area. In a good day, a 15.4 radio, which is what we are using, is going to give you from 50 to 100 meter range. So ideally, each floor of the building should be able to fit inside a 100 meter radius circle. In case of the firmware update, which is an important part of the requirements, according to CoAP specifications, we are transmitting those firmwares in 1 kilobyte blocks with a tiny ID so that the device knows this is the first block, or the second block, or the 40th block. And he can update after everything has been received. This little ID, it's 16 bits. That means the biggest firmware update we can send is 65 megabytes, which should be more than enough for any type of these devices, but it is worth noting nonetheless. Now, these networks tend to be very lossy, and they tend to lose packets. Right now, we are relying on CoAP's confirmable messages to make sure that retransmission is triggered if there is a packet loss. However, this might or might not be enough for us such a big transfer as a firmware update. Now, we are also expecting the access point to have IPv6 internet networking, which is a reasonable expectation, if not 100% true everywhere yet. So it might not be, depending on where the building is located. Even if we have the network, though, the firmware update process can be a bit slow. Some papers we read told us that we can expect about 1.4 kilobits per second of throughput on the network we're expecting. And for an example, the devices we've been given to work with can handle a 500 kilobytes update, which means that an update in the best case scenario will take at the very least 6 minutes. And in max number of devices, given the IPv6 addressing that was explained before, we are able to address a maximum of 4,000 of these devices per room, and we can handle about 60,000 rooms and about 60,000 floors on top of that. Next slide, please. Awesome. There is, however, some other things. Yes. There is, however, some things that will be good to keep defining. For example, though we know what kind of devices we're working with, we haven't decided exactly which CPU and sensor we're working with. And although we know that the protocols we're using support DTLS as a form of security, we still need to sit down and specify how to configure this. Next slide. This is a thank you slide. Quick conclusion. So as a challenge specified, we made a network architecture for management and configuring the fleet of IoT devices, which is a scalable, 100% open source, out-of-the-box supports thousands of devices, has a very intuitive UI which you can see and configure the network, and it's event-based so that we lower strain on the network. We would like to also thank the Riot OS team that were very helpful throughout the challenge, specifically Kuhn, who came every single day to answer our question for hours on end, and the Future-IoT staff for this wonderful opportunity. Thank you for listening.
Okay, robustness of your solution. Can you say something to it?
Of course, if robustness means ability to survive network imperfections and packet transmission loss, we discussed as in limitations. The QoA protocol supports trigger and retransmission of packets that are lost due to network imperfections, and we are relying on that to resend packets that get lost midway.
I understand that the most of your work has been focused on
Is the Aclio AWS challenge. Challenge 5, yes.
You start, right? Yeah, we start. Okay. They have the. Oh, yeah, they have. You have the pointer? Maybe you can explain. This is the pointer? Just a second. No. It doesn't work?
So it works very well.
But it's slow.
When you go a little bit away, there is a small delay. Be careful. Maybe 1 or 2 second delay. Here, very good.
Okay. When you're closer, it's growing, right? Okay. Okay, everyone, are you ready for challenge number 5? I cannot hear you. Shout it out. Mark Oliver, shout it out, please. Yeah, that's the feeling. We are challenge number 5, and we are here to explain you about how we integrate the firmware for Aclio and with the network with Amazon Web Services using the novel networking LoRaWAN. So let's see how it goes. Okay, so this is our dream team. We people from Brazil, Dimitri, and also from Colombia. We have 2 guys, Sebastian and Ivan. Me from Peru, and also France, some guys from Amazon, who also, they are some colleagues who help us to deploy, you can see in the picture, and also Professor Lauren from France. And I will explain you what is LoRa. So maybe many people are here, what is LoRa about this? The meaning of LoRa means like long range, which is a novel protocol for communication. And it was made by Semtech, a chip manufacturer from the States that was inspired for the communication of the bats and the dolphins with a low frequency radio. And they are transforming into a new protocol system, LoRa, basically specialized for IoT equipments. So we need to differentiate what is LoRa and what is LoRaWAN, because LoRaWAN is a protocol, but LoRaWAN is about the network, which is about, you can see here the advantages, like very different from the Wi-Fi and 3G or 4G cell phones providers, right? The difference is, the main advantage for me, I can say, is like for LoRa, I mean, you can have a huge range of range. Like, for example, you can see 2 kilometers in urban areas and 30 kilometers in countryside. And also the low power consumption. The promise is they can last 10 years and even more. So let's see. In the other hand, also they have the unlicensed spectrum, so which means it's free. You can transfer as much as quantity you want. You don't need to pay like 10 euros for 10 gigabytes for, I don't know, O2, I don't know. So you can see the advantage for this, and also the Wi-Fi, because with the Wi-Fi, I mean, it's very good at home and it's free also, but it's very limited wide range. So here are some of our supporters during this project, which is Amazon Web Services. They claim to be the more flexible and secure cloud computing, because they have some customers like military customers, bank customers, and government, and very sensitive information infrastructure. So Amazon Web Services, you know what I mean. I don't need to explain more about this. It's a monster. Here, Acleo is also one of the supporters, which also they also claim to transform this new revolutionary technology, which is LoRa, LoRaWAN, to the market, and they also connect about the systems of the IoT devices to make it also functioning in this network. And later on, we have the next explanation with amazing Ivan. Please enlighten us.
Thank you. So, as we have seen before, so LoRaWAN is a networking protocol. So the idea is that you can have end devices that can last for years. However, when you wanted to use that, you are sticked to a certain network provider. So the challenge here is how to use this architecture that is already present to a certain amount of end devices and to transfer some reconfiguration through that without the need of go physically to the end device. So to do that, what we propose is to use something called
So I want to come back once again to the point what has been given to you and what was the add-on that you added to it, because even though you had a point to it, it's still not clear to me which parts are the things that were already provided and which are the things that you added.
So yes, so Aclio provides us an end device, then and firmware. That's all. And then on the other side, they provide also an access to the IP core platform. And AWS provides us a cloud where we can install everything. So all the rest of the work was done by us.
And what was the biggest challenge you've had to face?
The biggest challenge was the serial communication between the end device and the computer to pass the commands, to receive the keyboard part in CoreConf, and to translate it into the actual changing of the behavior of the end device.
Okay, thanks.
How did you test the solution?
We send a command and say if it change the data rate.
Just one command, one time, or a little bit more than that?
No, we send several, and yeah, our implementation, our architecture, we are confident enough that is robustness with the standards that we adopt. Our implementation, specifically developed, is a proof of concept, of course. Also because in a real-life development, there would not be needed of a middleware layer to do those translations. That would be flashed directly on the firmware of the device. So we need to get in between that. And that was kind of complicated and was, of course, a workaround to show as a proof of concept how we enable that.
Thanks.
Okay, then a big applause again to the team. And that brings us to the last challenge, which is Challenge 2, IMT AWS, Automated Analysis and Synthesis of Multimedia Data. So, challenge team number 2, please. So for those of you who might have noticed, the clock is showing the time. It's showing 8 minutes plus 2 minutes for demo normally, plus 1 minute overtime, and that means when it's over, you're already at 11 minutes.
I don't need a slide to start. Yeah, right. It's so good to be back on stage with my friends. What an amazing week it has been, right? Big round of applause to the organizers. They have made, come on, let's actually do it. Thank you. They have made an amazing job at organizing this event. Wow, we are what, like 40 people? And the organization from the lights to the stream is fantastic. But such an event wouldn't have a lot of repercussion if it didn't have a strong online presence. Oh, my bad. Sorry, which button is? Thank you, thank you. Oh yeah, great. Thank you so much. So this is where our work comes in handy, improving the online presence of the event. Now, if you ever go to France, in Paris, you will notice that we do not speak English. If you want to do things in France, if you want to be heard in France, you have to speak French. So if you want to be heard on the internet, you have to speak the internet. And I'm talking about memes. Remember, it's an image with a caption, and it's usually funny. So this is what we have done. We have been making memes for a week. Sorry about that. Oh, thank you. So our base material is the YouTube live stream, which is being set up every time we have a conference like that. And from this live stream, we generate a meme based on keywords that the user has inputted. And now, on to the solution.
How do I press? Oh, it's a bit slow. Okay. Okay. So, yeah, we started off, there was already a challenge similar to this last year. And we thought, yeah, we can build on top of that. But that was a bit of a challenge. And these are the reasons why we started from scratch pretty much. So the GitHub from last year, there was no requirements TXT. So first of all, it took us a long time to install everything individually. Then there were no installation instructions in general. So all the stuff that you had to install from the command line, we had to figure it out by ourselves, how to install it. And we also found out that there were Google APIs used and Amazon access keys that we didn't have until like Wednesday. The Google API keys we still don't have. So yeah, for that reason, we just decided, okay, we're gonna start pretty much from scratch. We also have a bit of a different focus. We are gonna do a UI, and we wanna do some more intelligent way of choosing images. So that's why we decided, okay, we start with a blank page. And what we did actually, you're gonna see here.
Thank you. So we create a meme from a user interface. This is a big upgrade from last year. It doesn't look like much, but it has everything that you need to create a meme. It has a text field where you would type in the URL of a stream, so you just really copy-paste the URL of this YouTube stream. Then you would type in a bunch of keywords. So in our case, relevant words would be IoT, automation, etc., Berlin maybe. And at the bottom, you have this button, which upon pressing it, will start the generation of a meme.
And the front end, Charles and our colleague Vittorio from Italy worked on it. So he was remote, which was quite a challenge, but you worked quite a lot with him. So then from the front end, I took the URL input data from there, and yeah, I cut the stream data into clips of 30 seconds because the stream is continuous, so we cannot take the whole information in, it's live. And I split it into video and audio. And then I continued working with the audio, and I transcribed it to text. And yeah, worked a bit more with the text, later more about that. And Samia?
Yeah, at this step here, we have, if I can say that, the more innovative parts, where we used the machine learning-based recognition of AWS services. So here, the aim of this step is to extract images from the video samples that was provided at the previous step. Here, so in other words, we take a video and then we extract an image, but this image is based in several criteria. That means it should be, or it should contain more significant objects, and then we will use it as an output to join, please. To join the phrase speech that was provided also in the previous step to provide an outside image or the meme for that we will display in the user interface for the end user. Maybe more in details.
And now, as you can see, the UI has taken this very good looking appearance because it is displaying an image with a text at the bottom and the top. There will be a zoomed in version later, do not worry.
Okay.
Thank you so much. So at first we had settled to use an HTML and CSS based solution to develop the UI, but it turned out to be a bit too complicated. So we switched to something that is purely Python based. We have a code that it works in Python, and an interface which also works in Python, so the integration is absolutely seamless. And since we only had a week and time to market was the absolutely important metric, so it was, I think, the way to go.
So yeah, we ended up using WX Python for the front end. And in the front end, so the user can input a YouTube URL stream, and he can input the keywords. And the YouTube URL stream I take here in the back end. With YouTube DL, I can access the YouTube stream directly. And then with FFmpeg, I can split the video information into video and audio, and also make these 30-second clips from the stream. And that audio information I continue using down here. So I transcribe the speech to text with open source technology. I use the speech recognition, which is based on Google and IBM APIs. And then I have this long text. And initially we thought we could split it into sentences, but when you're based on speech, there's no punctuation. So it's a bit difficult to build sentences, even with the spacey library. So instead I used noun chunks because I wanted something more sophisticated than just a keyword. So I extract noun chunks from the text. And then the extracted noun chunks, I filter them, which of these noun chunks contain one of the keywords that the user inputted. So that's this line here. And if I find a keyword in the noun chunks, then I continue to call this function that extracts the YouTube title, and I continue to call the function from Samia, which will create the image. She will talk about that in a minute. If there's no keyword in the noun chunks, then we will just continue taking the next clip and searching until we find in the speech a keyword that the user was interested in. So
sorry about the time. So here, in this step, we take as an input the simple videos that was generated one by one. And for each video that contains 30 seconds, we generate 30 capture. And then the objective here is to choose just one capture. And for us, we used when we generate the captures, we will generate a JSON file that contains all the label informations about this image. For example, label can be what type is this object, its name, for example. The name can be a room, a garden, a house, an animal, a person. So for us, we put a condition that we choose only images that contains animal or persons, or the two in the same image with the highest confidence value. And then the best image, that means that has the highest confidence, will be joined to the text, and we will create our meme and display it in the user interface. And that's all. Maybe we can show you a demo for that.
Would you click on the link, please? Yeah, it's dark blue. It's dark blue. Okay, here, remove it. And if you play the video, please. Yeah, sure. Please go on. Yeah, thank you. So remember, this event is also live streamed on YouTube. So we thought, why don't we apply our program to this live stream, right? Shall I run it? Yeah, thank you. So this was the live stream about an hour ago. I copy the link, I launch my Python program, and I copy paste the URL in the first field. Then I type in keywords which I think are relevant. And the program starts running and starts looking for keywords. And after 30 seconds, one keyword appeared. And it created this image. Now, as you can see, there is a title at the top, which is also the title of the live stream. And at the bottom, we have, just below the time bar, we have a chunk of words, among which is one of the keywords, environment. And this is how our project works. Thank you.
Okay, thank you very much. Very good. Yeah, my question would again be about robustness, or as Adam formulated it much more elegantly, how did you test your solution? Please come back because we have a special first program point, and therefore please take your seats again. So we found a vote, but as I said, I will only announce it at the end, so don't, yeah. So the Adam Wallisch, as you heard, was in many positions, and he's probably the one in the room that heard the most presentations of things of all of us, and he agreed of giving you some feedback to your presentations. So as I already said, we were very satisfied with the presentations, but nevertheless he has some hints for you, some highlights he wants to highlight, and therefore I'm very thankful that you agreed to do it, and hand over directly to you.
Thank you a lot, and I would like to use a few minutes, just a few minutes, to give a couple of impressions. So number one, in my opinion, the content of the presentation was better than the presentations themselves, for me. I liked more what you have done than how you have sold it. Now, coming to the selling points, most of the presentations have given much more attention and have been much more focused on how than on what. And that was pretty consistent, with some exceptions. But mostly the beginning, the setting the frame, where does it belong in the bigger picture, and then what was the specific problem which you'd like to solve. In other words, what would you like to see in case you are done? What can one expect? I will come back to my classical comparison or question, which I liked to ask and people hated to listen to. In some presentation, even in the European Commission project, pitches and whatever, I asked, excuse me, if you are done, can I eat it? Or will it bark? Or will it run away? So how can I imagine what will come out? What will be the outcome? You see? And that is extremely important that you start with that. You give the impression to the listener what it can expect at the end. That is the first question. And once you have done that, it's extremely important to say, at least very shortly, assuming you might have solutions, and usually you can imagine a couple of solutions, how would you evaluate the solution? Which one would be better and which one would be worse? And having that, you can give a very, very short, depending on the time which is available to you, analysis of the alternatives you had. Most of you presented something as if that would be the only way to go. And usually you have at least some options. I understand if there is shortage of time, you have to be very concise, but at least hint that you have thought about some alternatives and not just say, okay, that's the way we go, that we have to go. And where you can win the time is later when you focus on major aspects, on major innovation, on major elements of the approach. You don't have to list all modules and all sub-routines and all sub-programs and parts of the libraries which you integrated into your solution. And then you come to the result, how far you got and how you evaluate it. And then you can do it very quickly. And yes, you have to look at the watch and stick to the framework. In the old times of the European Commission project proposals, we used to have, for a big project with several parties, like 22.5 minutes. 22 and a half, and at the end the mic has been shut down. No matter whether you have been in the middle of the word, in the middle of the sentence, nobody cared. Bingo. So that is something which you have to look at. But the most important from my perspective is setting the scene, giving the goals, giving the evaluation criteria. And then you are fine. Okay, thank you so much. It was a pleasure to listen to that, and congratulations, you have done a lot in the limited time. That was something which I was very impressed by. Thank you a lot. Okay. I have to leave, I'm sorry. I have my email in case of questions. We have a jury certificate contact.
Yeah, I gave him already. Okay, perfect. So let me just finish this first slide here. Okay, good. So let me connect my computer. Zack. Okay, so I'm just a little bit confused with the certificates that are laying here. Yeah, so maybe let's start with our jury, because we have our jury here. So maybe a jury, I did not sign them. That is really bad. Do we have a pen here? Perfect. So let me quickly sign them. So we have Samira Franzel. Samira, please come to the stage. Here's your certificate, and stay there. Samira, stay there, because then we can make another photo. Even though Adam left already, but we are still there. Tim Kavaloon, second jury member. Big applause. Andreas Kosten, third jury member. Adam Wallisch already got his certificate. This is yours. And mine, and then we can just stand here and you can make a photo of us.
I look like the small son of Margot.
Okay, so these were the jury certificates, and so now here I'm a little bit confused why I didn't order these certificates in, but yeah, I can easily order them in. The second range of people that I would like to thank is the staff. Can we show? It's unplugged. That's a good reason why it's not visible. Very good. This is why you need good people in your team.
Good.
Perfect. Okay. So the second round of people are the staff people, and for that one I want to ask Fabian on stage. So with Fabian I co-organized the school in 2019, and since then we are in very good contact, and it was a big pleasure, like it was a big pleasure doing it this time, and he was really one pushing that we organized it, that we put it to Berlin. He created the contact, and so yeah, thank you very much, Fabian. It was again a great pleasure for me. Then we have Tim as a staff, so you get many certificates, well deserved. So yeah, Tim joined us from the beginning, and he was really a huge help because he was really organizing lots of stuff here together also with Samira, and so he helped me. He took a lot of pressure and works from me, and so really big thank you to you. The third one is Samira. Samira, big thank you to you as well. Yeah, so Samira, you also you helped a lot during the organization, for the communication and so on, and with you two it was really a pleasure running this event, and I would every day do it again. Thank you. Then the third one is Lars. So Lars, please come to stage. So Lars and Erkin, they are from my stuff in Munich, and these two, we worked like the weekend and all the on-site stuff they worked on. Lars was focusing on the stream, having lots of headaches with dying computers and so on, and you did a wonderful job, and it's like always a pleasure, and I'm very thankful having you in the team because you're really carrying the work, so really thanks a lot for that. And the next one, Erkin, same for you. You did a really amazing job, and they are very different characters with different strengths, and so it's really a pleasure having you two in it. I think nobody could have gotten and distributed the food better than you, for instance, moderation, the joke time, and so on. So thanks a lot to you as well for carrying this. Without you two, it would be impossible. Thanks to my wife and my kid, as I already said at the beginning, without them it would not have been possible. My wife unluckily got backache from carrying the kid. The kid is fine, but cannot come alone to the stage. And also a big thank you to my assistant Fabienne, who unluckily already had to leave. So she was also a really big help on site for taking care that you were available, taking care of the well-being. So yeah, you can still clap for them. Then also a big thank you to the team of Emmanuel for supporting the challenge. So Emmanuel, you're just coming. We also have a certificate for you. You can come to the stage. The same for Kaspar Schleiser and also Sören Köhn-Sandberg. If you're here, please come over. They're all the same, but they have your name on it, so you should take the right one. And also a big thank you to Paul-Guillaume Meunier and Cosima Stocker from the German-French Academy for supporting this event from the beginning and also doing work in the back end. To Katharina Voss, Katharina Berning, and Antonio Stubbe from TOM International for supporting us, especially with the invoicing, so they will still have some work afterwards, and also with the hotel booking. And also to Maria Leprovost and Ulrike Traum from the Deutsch-Französische Hochschule, because without these people, it would be much more difficult to run the event. I myself don't have a staff certificate, I don't know why, so I put the one of Paul, and then maybe you can make a photo. Maybe everybody come a little bit closer. Yeah, so really big applause to those. All right, and then I also handed them partially over the speaker certificates, so some of the speakers are still present. So the first speaker, so I just took care that I'm on every photo, therefore I have a certificate there. So was the first speaker. The second speaker was Falco. I would maybe hand it over to one of you for Falco. Then the third speaker was Pierre Parent, who joined us online, so I will take that one with me, so Fabienne can send it. Then the next one are Fabian again. Benjamin Schader, yeah, please come to the stage again. Benjamin, thank you very much. Antonello, and Florian, if you're still there. Even though we desperately missed you on stage, we're very happy that you were here, because you're also always bringing happiness to the event and doing so many works. We have Pascal Travers, who already left us. We'll send it to him. We have my dear, wonderful colleague Laurent Tuta. And we have Antoine Wacheux. And Guillaume already got his certificate. So I give it to you, and yeah, we can do a photo. And then afterwards, let me also all give you the group photo. Yeah, I can also go in the middle again. Yeah. So wait a second, because I mean you can clap, yeah, but you stay on the stage, please. Okay, yeah, thanks a lot again. Okay, very good. So, or actually come to the stage once again, because we forgot something very important, and let me just get it. So yeah, speakers come to the stage again, because we forgot something very important, which all the participants will also get. These are the goodie bags. So in the goodie bag, you will find our 650 milliliters water bottle that I wanted to give you on Monday, and it has a logo and it's dark, so it should be really cool in summer, and it should also be undestroyable because it's tritanium or whatever it's called. Then we have the in the school famous, and you will love it, muesli bowl from Siemens, which is a wonderful tool if you're on travel. So both things together. Did I throw something in?
No, no.
Okay, it's okay, good. And then we have a bottle opener from AWS that you have inside. And then you have also something for your privacy, for your webcam from the Einstein Center. You have a pen from the Einstein Center, and you have quite some different stickers and another pen from Siemens. So very, very good items that you have in there. And yeah, so I also want to hand it over to you.
Thanks. You forget the opener. Yeah.
Oh yeah.
Sure. Okay. As Mark mentioned, there's a pen from Siemens inside. Just wanted to mention that it's really good to sign contracts. So don't hesitate to contact us afterwards.
And in that direction, if you, at the beginning, we had also the opening by the German chapter of the ACM. If one of you would be interested in joining that one, feel also free to contact me about it. So now we come to the participants, and I ordered the participants by challenge. And yeah, so we'll again also have the challenge organizers on stage. So the challenge organizers of the autonomous guided vehicle for the factory of the future are Florian, Antonello, and Benjamin. So please come again to the stage. You can leave your certificates there. You won't get another bag, but you will get another certificate. And the participants are Armani, Sandro, Juliette, Lucas, and Mohamed, and Milko. Please come to the stage so that you get your bag and your certificate. Perfect. And you will also let's make a photo, and then the people can clap you. In the meantime, I will give you the photo and the back. Okay. Ready? Look into the camera. Perfect. Okay. So you can give them a applause and stay here. Stay here. I mean, you can be your own stuff. Wait, you also get the back, unless you don't want the back. Yeah. And we can give Fabian, right? Fabian, Felix, a big applause for this great picture you also Okay, so the next team is the integration of an Aclio LoRaWAN gateway with AWS Smart Territory Framework, and for that one I asked Laurent Toutin and Antoine Bacheux on the stage, together with Jose, Shama, Ivan Dimitri and Juan. This one is for Tim. And this is a photo with the jury. Everybody is standing there. Tim is drinking his coffee. It's a very good photo. I have some more. I mean, I just found it funny, therefore I wanted to give it to you. And Samira, you don't have a really compromising one, actually. But you have many where you look very interested, so maybe I give you this one. Very good. Okay. And for Lars, I also got one. So and for Andreas, I also got one. I'll give it to you afterwards. Or let me check which one I had for Andreas. Just before. This is why I was late for lunch. I was preparing these. Okay, yeah, I also got one. I got one for Andreas. All right, good. So, but even though it was a nice activity, it diverged me from my actual task. I wanted to sign the challenge winner certificates. So let me see who won the challenge. Okay, do I still have my pen here? Okay, good. So, hackathon challenge. These are the trophies. And here are the challenge winners. And so these are the, yeah, so we can go to the next slide. So here you see all the challenges again. They can all have one. Okay. Maybe to give you some feedback, I mean, I did it before, so all the challenges were very good, and you did a very good presentation. We have seen that you all did very good works. There was quite some range between the activities in the different challenges, but overall the jury was in one voice in deciding who is the winner. Yeah, but as said, nobody lost. This was just for the criteria that we had to select one. You can certainly be all very, very proud of you. I think I don't have to tell it to you, but you did an amazing job. You made new friends, you had a very cool week, and yeah. But we had to come up with one winner, and the winning team is the automated analysis of streaming data. And therefore, once again, please, Samia, Katrin, Charles, and the two online participants, Lucas and Vittorio. So let's put the online here. Congratulations.
Thank you.
Congratulations. And congratulations. And also, Lars, yeah, we hand those over, yes. So these are the trophies. In order to transport them, you can unassemble them. So the round thing at the bottom is just paper that is clicked together. And then you can also put them just in an envelope. And yeah, so we hope you enjoyed. So Lars, maybe come also on it, because we were the two challenge heads. And yeah, a really, really big applause for the winning team. Yeah, exactly. So Vittorio, if you follow us online, and Lucas, yeah, big congratulations to you. If you let us know your postal address, we'll send you over the certificates and also the winning trophy, of course. Good. So yeah, and what was especially impressive was also that you had the very good remote work together, that you structured the challenge very well, that you integrated different technologies, that you had a working prototype, also that you did a very good presentation. So overall, we were convinced that this was a very good presentation. From the scoring, the other teams were not endlessly far away. This team was standing out, so it was not only 2 points different. But overall, as I said, you all did an amazing job. All right, good. So we did the follow and everything, yes. Yeah, then we are almost in time. So Lars is always telling me that we are running too late today. We are almost in time. So therefore, yeah, finally the week is already over. So, I mean, you know it, that we started on Monday morning. It looked like, oh yeah, it will be endlessly long. But in the end, the time was flying. I didn't sleep too much this week. Lars and Erkin definitely also not. Fabian also not. And you probably also not. And for me, the week was really flying by. It was a blast working with you, each individual of you, getting to know you. So it was a pleasure having you on site. As usual,